I'd like to introduce you to our presenter. Dave is one of our applications engineers in Omaha, Nebraska. Some of you may know Dave or Bill from training either at one of your facilities or at our facility in Omaha. So go ahead, take it away, Dave.
Okay, so yes, this is the second of the three-part series. And if you were unable to attend the last webinar, then you can still catch it at Productivity's website, so productivity.com/webinars. I want to point out that I'm talking about probing here, and really what I'm covering is Haas probing, and they refer to that as WIPS, and that means Wireless Intuitive Programming System. So some things are similar on different machines, but I'm specifically talking about the Haas probing system. And what we're after today is we're trying to help people get the most out of the technology that they have. And that means that we need to take a look at the capabilities that is already in the machine control that you're using. And you're probably already using probing to set up your parts. And you know how to get what you need for both tool and work offsets. But if we want to make this a custom cycle, we need a template program, which is what I'm going to show you. But before we get started on the actual work setting, I'm going to talk about tools for a second. And if we have a tool, we measure it. You know, if you're used to doing it manually, you might use some shim stock or a piece of paper or a gauge and set your tool on top of your part. But the way the system works nowadays, really, we just need tape measure. Bring it in and get an approximate value of that tool length and use that number. So if we look at that, we have a tool, we measure the tool, and we can plug it in to the approximate length. So here I am in the offset page, the tool offset page, and if you can see, I'm moved way over to the right. So I'm at the very last columns here, and I have an approximate length, an approximate diameter, and I have a probe type, how I want to probe it. And we'll talk about these things so you can see how this is done. So before I get too far along here, I want to talk about that we can clear things out here. And I want you to see that we have some neat extra features here nowadays with the next gen control. And one of them is these two guys here. So one thing I can do is I can clear out a column. So under the probe type, if I'm starting with a new setup, I can actually clear out this entire column and reset each of these tools to whatever type of cycle that I want from the probe. Or I can clear out an entire tool. If I just have to remove a tool, I can clear out the whole row. Likewise, I can also clear all the tool offsets. I can wipe the whole thing clean if I want to. And I can wipe all of them clean except for the probe. So that's a very handy one, just to get rid of everything. But of course, I still need the probe offset, so that would stay. So those are very handy to have. Under the probe type here, I'm going to press F1 here. And we're going to have the different ways that we can touch off a tool. So obviously 0 would be none, no probing. But I can set up 1, 2, or 3 here. So length probing, rotating tool, this is where the tool is actually going to spin to touch off the tool. And this would be used for things like face mills, but not exclusively to that. Length probing, non-rotating tool would be for drills, taps, and in mills that are smaller than a 1/2 inch. And then the last one, length and diameter, rotating the tool. This would touch off in mills so you could have a diameter offset in your offset page as well. So we would set those as we needed. And when we're ready, once we have all the approximate lengths and diameters all set, then we can go to tool offset measure. And I really like that this is the button that they're using. If you're used to older machines, 20 years ago with Haas machines, you could bring a tool down, touch it off on top of your part, and then you would hit tool offset measure, and it would record the position of where you were. So it would record that, and then you could hit next tool, and it would go up and change to the next tool. So it's a real handy button, a really handy way of setting your tools. So it's still that handy button to push. And in this case, when we push it, we get these options. And I primarily want to talk about the first one and the last one here. So if we press 1, we can just probe the tool that we have highlighted. But if we press 4, we can probe all the tools. And by all tools, what that means is all the tools that have something in under probe type, not none. So in this case, you're really only 3 tools. And this is exactly what I'm going to do here in a minute. We'll probe these 3 tools and you'll get to see what that looks like. So if I press 4, then I'm going to get this window popping up, and it says that it's going to probe the selected tool, and I'm going to run it in MDI. I hit cycle start, and then this would be the programming that I would get. We won't go into those in detail here, but it would run this, and it would look something like that. So first we have a drill coming down, and this is non-rotating. And an end mill is going to come in. And with this one, it's going to shift off center. So you see as it comes down here that the end mill is off center. It'll start spinning, and it's spinning backwards. It'll start by touching off the length. Then we'll shift back to center and set its diameter. It first does one side, and then it'll do the other side. So this particular function will set not just length, but also the diameter. And then one more tool, the face mill. So this is too big to just go down the center, so it also shifts off center. Gets into position here, and it'll also spin. But it's only going to set the length. So with the face mill, I probably don't need to set the diameter in my offset page. And it's a bigger tool, just makes sense to just touch off the length. Okay, so one more time with this is the code that we would get if we were to hit cycle start, and it would put the code in MDI, and this is what we would get. And you can actually take this and save it. So what we could do is, it's a nice feature to be able to do this, where we can snag this bit of code and save it, maybe put it in a program so we can have it ready to go to touch off our tools. And by the way, I should point out that once it's in MDI like this, it's not just stuck in MDI. You can actually press home and then type in a program number to save it under, and press the Alter key, and that will save that program into a numbered program that you can then use however you want after that. Well, that was tool setting. Now let's look at using the conversational programming to build a custom cycle. And what we're after here is to take what we already know how to do in our conversational programming and stick that into a template program that helps us to produce what we need, what we want to run in process. And by in process, of course, I mean that I hit cycle start, all the offsets are updated, and then it machines the part. But we're going to examine this template first. So here's a template program, and basically what we're doing here is using the same sort of programming we might do for any other tool, calling up the tool, getting in position. Big thing here is that we don't ever spin the probe. This will be one of the things I would give you as advice. Don't ever spin the probe, because you could end up breaking not only the stylus, but maybe your probe. So you notice that there are no commands to turn the spindle on in any of these programs. Okay. So in the programs, as I go through them, you'll usually see at the top some sort of a comment explaining what I'm talking about in this particular moment, and there'll usually be an end code at the top as well, indicating what segment of code that I'm actually working with. After that, we'll have a default line. So these are codes that are default codes that when you turn the machine on, these are active, and we're just making sure we're getting back to those defaults. And then we'll call the probe up. Then we're going to move into a position wherever we need to be in X and Y, and calling up the current active work offset that we've already set up, or that we would do that manually. Right? So we'd have that already set up, and then we'll come down in Z. And you'll note that my Z value there is somewhat large, 3 inches. I'm staying away from the part on purpose, because at this point here, the probe is not on, it is not protecting itself, and I want to make sure that I steer very clear away from the part until I'm ready to turn it on and move in closer with a protected position. So next we're going to turn the probe on, and so this is where we have a code that may be new to you, G65. If you're familiar with using codes like M98 or M97, it really is the same function. It is a subroutine call. This is a global subroutine call. So it's actually calling a program, program number 9832, and this program turns the probe on. I should point out that many things turning it on, like coolant, M8, there's just an M code, turns it on. In this case here, it's a little bit more involved, because not only are we turning the probe on, but we're testing it to make sure everything's working. So the program 9832 is doing a few things. It's, to our purposes, it's just turning it on, but that's what that is. This line, though, is a very simple line. In this case, it's just running the program. It's the next line that's of interest to us here. So when we have a G65 9810, this is a protected positioning routine, and we can go X, Y, or Z to move. And you can think of G65 P9810 as similar to just G1, but the difference being the probe is on and it's paying attention. If anything should trigger that probe in this, from the 3 inches of Z down to minus 0.3 inches in Z, during that time, if it gets triggered, that you would get an alarm, which you'll see later. So what happens when we run this? So here's an example of that. It's going to come down and go into that hole, because if you notice that we were at X of 1 inch, so it's going to shift over to that. We'll go ahead and run this. So it just drops in the hole and comes back out. That is running this program here. So it would drop in the hole here, and then it turn the probe off and go back up to home in Z, machine coordinate Z. But let's say that I put the part in there wrong. I flipped it over and put it that way. What would that look like? In this case, we would get an alarm. The alarm that you would get would be that 1086 path obstructed. So something happened, it hit something, and the machine just stops. This is what we want, because if nothing else, if we didn't intend for this to happen and it did, then we can come to the machine and go, oh, that's not right. I put the part in there wrong. So this is an important bit of code that you need to use when you're doing in-process programming, where when we do it manually, we manually place it close to the part. In this case here, the machine is taking care of the whole thing, so we need to have that just in case a part was misloaded, something's in the way that we didn't expect, whatever that might be, we want this in there. So with our template program here, we've done everything that we need to do except for the actual cycle that we want to follow. We want to do some kind of probing cycle, and that's what I'm going to talk about next, is how to build our program at this point right here. Okay, so how do we do that? Well, what I like here is that on the next gen control, we can just go directly to our work offsets. And what's really nice here is I can go in here and pick the offset that I want. So I just come down to whatever I want. In this case here, we're going to be doing G54. So I highlight the one that I want and I press F3, probing actions. Here I'm going to get a menu, a visual menu of the different types of options that I have that I can pick from. And we're going to pick the bore, but there are various other ones here that you can see. So we'll pick bore. And at this point, we go into the actual cycle itself, the actual fill in the blank page. And you see that it's already incorporated the G54 here because that's what we had selected. Whatever one we had selected, that would show up there. The only thing that's really required of us is to put in the diameter, which in this case here, a 1/2 inch is a good approximation of the hole size that I'm going to be drilling and wanting to probe. The X and Y that you see here allow us to actually shift off center. So when we probe this with 0, 0 on here, it's going to set the work offset to the center of that hole. But if we want it somewhere different, like maybe a corner up here or something, we would put in whatever that distance is in X and the distance in Y to move it to that corner. I'm not going to do that for my example here. I'm just going to leave those as 0. So we do this, we hit cycle start, it's going to run it in MDI, and we're going to get this bit of code here. So this is what it looks like on machines that are coming out of the factory today. And you see this line of code here, it's all comments except for this one line of code. And if you don't see this when you're doing your probing, maybe you see this line down here. So this is on older controls. On some older controls, not next gen controls, they actually did have this line as well, but or it was possible. On some machines, this is the only one that's possible. So I went ahead and put both of them up here so you can see them. But I'm going to put this line of code in my program now, and there it is. And now I have the program that I need to automatically probe a hole. But let's take a look at this line a little closer and examine what's actually happening in here. So start off with the work offset. So the W on what I have in my program is 54. That's my work offset 54. And you can think of it's nice. You can think W stands for work offset. On the older systems, they used S, and actually S is a common code that's used within the Renishaw programming. S is used for work offset in all of what Renishaw does at their on their programming. The A designates what cycle we're actually using here. So we're probing a hole. So A10 means probe a bore. And on older systems, it was A1. So we don't really need to worry about that A value, but I'm letting you know that it's, I guess, that it's different between older systems and the new system. And then we estimate the bore size, and it's important to realize that this can be an estimate if you want. And an estimate usually works just fine. Whatever you can look at and see, well, it's about a 1/2 inch hole, that's probably good enough. So D for the diameter. And then we have these X shifting and Y shifting that I mentioned earlier. That's the E and the HR, respectively, E for X and H for Y in this case. And on the older systems, it didn't have that as an option, so it's not listed in this bit right here. All right, so we're going to run that. I come in, drop in that hole like we saw earlier, but now it's going to probe that hole. Okay. So when we do this, I also want to show you that there's a little bit more going on than meets the eye. So this is the line of code that we put in, and sure enough, it sets our X and Y work offset values for us for G54 as indicated with the W. But there's something else going on here too. When we probed this hole, we assumed it was a 1/2 inch, and if we go into the current commands and under the macro variables, you can see here that there's a variable lit up that is showing us what it measured for that hole size. So we approximated a 1/2 inch, but it's really something bigger than that. And I'm going to refer to this as variable number 188. I know it's listing 10,188, but we can actually drop off that 10,000, just remove that from this. So think of it as being 188 and just use that. That's a legacy thing. So on next gen controls, they use these larger numbers, the 10,188, but we can still use pound 188 as our variable number. And on top of this, I want to show you one other little thing we can do. If we go into the current commands and find the timers, and this is very much the same on the older controls too, it's just page around until you see a page that looks like this. And there's macro variable or macro label number 1 and macro assignment number 1. And you can see I put in size for that, for the label. And under the macro assignment, I put in 188. And over here on the bottom, so this would be on the bottom of your screen when you're in memory, you would have size listed here, and whatever was probed last. So somebody probed something here that was approximately an 1 inch and 1/8, and this is what it fed back to us after it probed it. It gives us this number. So whatever you've done last, whatever size type function that you may have run, whatever the last one you did, this will always be there. And I find this would be very handy as you're running the machine to see just a quick glance, and you can see if things are correct or not. So you can use this however you want, but it's a nice little place to show what size something is. And these variables, the 188, and there's a bunch of other ones. I'm not going to go into that in very much detail on this particular webinar, but to let you know, you can get a programming manual. This is a Renishaw book that you can get as a PDF, and I've listed what the program manual number is here, but I also put a search down here. So if you do a Google search for Haas Renishaw Programming Manual, you will find this PDF file. The actual links to it are quite long and very convoluted in what they are, so I didn't want to give you something difficult to write down if you were wanting to write it down. But a quick search and you should be able to find this manual. All right, so with that, I'm going to go into an actual example now. And we have a block of material in a vise, and we want to probe the top center. So all I've done here is put a program together using the template and using the conversational programming, and this is what it would look like. So first it's going to center itself over the block and touch off the Z. Then it's going to go to the left side and the right side and get the center of that block in X, and then the front and the back and get the center in Y. So this is a bit of code that will find the top center of that block. So we are going to do a tool call like you saw before. In this case here, I'm going to move to a G54 X0 Y0, which should be the center of the block. So I had to already get that approximated before I could run this code. It will position itself 3 inches above. Then it's going to turn the probe on and move into position. This is a protected positioning. The 9810 is protected, and it's going to bring it down to just a little bit less than 1/4 inch above the part, moving along at 75 inches a minute. From there, we're going to do our probing. It's going to probe, first of all, this line is probing the top of the part. This H value is how far it's going to look for the part that's 300,000. So this is more than the 200,000s that we were sitting above it. So it will find the part. And when it's done with that, we have to turn the probe back on, because anything in the conversational programming, a line like this one, is going to turn the probe off when it's done. So in order to make this work, if we want to add more than one of these cycles, then we have to turn the probe on in between. So I'm going to turn the probe back on, and then this cycle here is a center of a block, outside of a block, and it's going to look at 3 inches along this direction, 1.5 inches along this direction, and it's going to come down 1/2 inch to probe around the outside. Following that, well, I'm sorry. So what this is doing is it's setting our work offset, G55 or 54 here. So that's the 54, this one for Z, and this line for X and Y. It'll set everything based on both a single surface hit here and a rectangular block that you see listed up here. Once we're done with that probing, you'll see that it'll turn the probe off and return to a machine coordinate 0 for Z. And once again, we'll take a look at that. Now I need to point out that the part that we're making, so this is a bit of code here of actual machining, and you'll see the machining in a second here. We're going to drill a hole in the middle. We're going to mill along this side, and we're going to drill another hole that's off center. So this is showing what that machining would look like. Now we've only machined one side of this part here. The other side we couldn't because it was inside the vise there. So we're going to flip it over and do some additional machining here in a minute after we do some probing. The deal here is that we can't get at everything, and this little hole is a blind hole. So we have to get it from this side, and we have to get one side only of this side versus this side for the first clamping. So we're going to have to switch the part around. Okay, so now that it's in there, we're going to probe this hole because we want to pick up that center again. We can't do around the outside of the part anymore because we've cleaned up one side. So we're going to want to clean up this side, but we want to find where the center of that hole is because that's important to us for whatever in the part feature. So it's going to come down, and we're going to still do another Z just to make sure. And then it's going to come back over to the center, drop in the hole, and get the XY from that hole that we drilled previously. And let's look at what that code looks like. So like before, we're going to do all the same stuff that we did in the past. In this case here, we're back to an X of 1 inch to probe off center, somewhere in the middle of the part. And we will turn the probe on and get into position. And then we'll probe that single surface in Z and hit that to get that updated. We're also updating 54 again here. Then we're going to turn the probe back on again because it shut it off. And we're going to move over to the center and down inside that hole like what you see over here. With that, we will then do a hole. We'll probe the hole. And then turn the probe off and go home. One more time. So Z, move back over, back in the hole, and get our X and Y through doing a bore. And with that done, we can then machine that, and here's a little bit of code that does that. And done. All right, so what do we cover here today? We covered doing auto tool setting. We talked about how to do that, how to go into the offset page and pick the cycles that we want to do for each tool, and then just run. And then we looked at how we could put that into a program. We can actually save that MDI code and put that into a part program so it would automatically do that setup. We looked at the machine capability in this respect of what we can do with the machine that helps make our lives easier. And then we used what we knew to create in-process programming so we can touch off our part automatically and using a template to do the protected positioning and find those work offsets.
Thank you very much, Dave.
Mm-hmm.
And we do have some questions from our audience. So I am going to bring just a little page up here. If you have any questions for us for today's webinar or future questions, we do have our email posted up in front of you. So let's get to the questions. We have a number of them. So starting out, Tim M is wondering, is there a way to measure a tool length and diameter with no rotating?
If you're going to be measuring diameter, you have to rotate. And I guess technically you could. It's not built into the intuitive programming that's in the machine, but there are ways that we could probably accomplish at least the length could be done that way, and then we could do the rotating as a separate thing. So that's something that we can bring up in the third in this series, which I will make a note of.
Okay, thank you. Also, can we measure tool length non-rotating off center like a face mill?
So yes, you can. That's in there where one of the options that we have on the machine is to do a manual. So you would have to position it there and then line up the cutting edge and then run a manual set. You couldn't do it the way that I was doing it there, but you can do it, yes.
Okay, thank you. Mm-hmm. Bill is asking, For someone who doesn't have a machine yet, is it okay to keep the probe in the machine all the time, or should I remove it once I finish my setups?
No, it can, most of the time that's exactly what we do, is leave it in the machine. That is standard practice.
Okay, thank you. How fast can you safely feed in 9810?
Well, I usually go 100. In these examples I put it at 75, but I usually go 100. I think you can go more than that. I guess I don't know the exact number on that. I don't know, Bill, do you have an answer for that?
Their published thing just in the Brenneshaw inspection book just says the maximum safe fast feed rate established during installation. So I'm guessing it goes as fast as you can feed on the mill. But normally we operate somewhere between 50 and 100 inches a minute.
Okay, thank you. Taylor is wondering, does productivity or MMT have a cheat sheet for WIP's A values? By this, I mean a sheet that says P9023A1 equals bore probing, S for work offset, D bore diameter, P9023, because I'm working on machines with classic controls.
I do not have a cheat sheet. That something like that could be made, but I don't have one, no.
Okay, thank you. Carl is asking, when using G65 for another portion of the program after turning the probe on, does this turn off protected position as well?
No, you don't. You're not really turning on or off protective positioning. Think of protective positioning like G1. If you want to do another protective position, you just have to call it and move the probe. So you can't do protected positioning unless the probe is on, though.
Okay. Ed is asking, he said, I rarely have student probe issues, but I think I may switch to probe program library just to show and let them use without answering the questions and programming the probe. Like, how far down do we go in Y web without hitting vice or the 3-in-1 cycles?
So I'm not sure I understood all of that, but so there is a technique that I'd like to use as far as how far down do you go. What I'll do is, if I'm at risk of hitting something else like the vise, then I actually start by positioning the probe above that surface where I'm wanting to avoid, but in a place where it would do the probing as I wanted, and then zero out the user coordinates for Z, and then move it back up and see where do I position it at that point? Is it a ½ inch? Is it an inch? What is that value that I get? Because I need to know what the incremental value of where I am when I start my probing cycle and how far down it's going to go. It's that incremental distance, not from a 0 point. Doesn't know what that is necessarily. So I just find out what that is through zeroing out the display so I can get that value. I know that's a little hard to follow maybe. So if that's continues to be an issue or something, if you're a little confused by that, maybe get a hold of us and let us know that you need some additional help.
9955 turns on the probe at the beginning as well as turn off at the end. Do we not need the extra 9832 probe on commands?
No, you do. You need it because you need to be able to do the protective positioning, and you can't do protective positioning unless the probe is on.
Okay. Stephen is asking, would a classic probe routine work in the NGC control?
Yes, I believe it does. I myself have not actually tested this, but the program that is that 9023 program is still in the next gen controls. So yes, it is still there and you still could use it.
Okay. Bob from Vincennes he just made a comment, just a quick word of caution when writing probe programs manually. I had a student type M03 instead of M30 at the end of a program. Spindle turned on at the last commanded RPM, in this case 10,000 RPM.
Yes. So that's why I talked about it never turn the probe on. I would look at, or never spin the probe, I should say. Just be diligent with it. Definitely check, make sure there are no, maybe just do a search for M3.
Okay, thank you. Ed is asking just to add make and save probe programs, especially for parts that are same setup like upper left, and also for a face mill to have rotate parameter set. I think that was kind of a follow-up to what he was asking before.
Okay.
Sean is asking, are there macros for probing over a length and have program adjust for that? And is there another macro for the A axis for leveling apart and then rotate it to the desired angle to start program?
So I believe those are actually questions for next week. So okay. Yes, I believe if I followed all that, that should be yes to that, but I will look at that next week.
Okay, thank you.
Mm-hmm.
Carl is asking, is there a list with macro variables and what they stand for so that you know what values are values you want to see on your home screen in the bottom right corner, or is that listed in the Renishaw manual?
That's listed in the Renishaw manual, yes.
Okay. It looks like that is all of our questions today.
Okay.
So again, I just want to say thank you to our presenter today, Dave Nelson, Applications Engineer from Productivity, and Bill Schnitker, Applications Engineer, for answering questions in our Q&A. Again, we thank you all for taking the time to join us today. We hope you enjoyed today's webinar and look forward to seeing you again soon. Join us next Wednesday for week 3 in our probe series, Advanced Probing through Macro Variables and Subroutines. So until then, stay safe, stay healthy, and thank you for your business.